On question number 6, we are trying to maximize x plus 3y. And we have these constraints here. And you'll notice that we have the normal x is greater than 0, y is greater than 0. But we also have x is less than 6, y is less than 5. So we have more horizontal and vertical lines. So this feasible region is actually going to be kind of like a box. But we do have one inequality that we do need to solve for before we can graph it. So x plus y is greater than or equal to 2. If I subtract x from both sides, y is greater than or equal to negative x plus 2. So I'm going to graph this on the calculator. I'm going to graph y is less than or equal to 5, and y is greater than or equal to 0. So any of the ones with y's I can graph in the calculator. The two with x's, I'm going to have to do that by hand. Now I'm ready to graph these on the calculator. So if we go to the y equals menu and type in negative x plus 2, 5, and 0, and then press graph, this is what our graph looks like. Again, it only can graph the y ones, so the x is equal to 0 is right here, and the x is equal to 6 is going to be right here. So now let's look at the shading, and I like to do the reverse. So it was y is greater than or equal to negative x plus 2. So the reverse would be shading below. It's y is less than 5, so the reverse would be above 5. And it's greater than 0, so the reverse would be below 0. And if we graph it, this is what our shading looks like. So this would be our feasible region. However, we still need to take into account x is greater than 0 and x is less than 6. So because x has to be greater than 0, we can cut off that part. And because x has to be less than or equal to 6, we can cut off this part. So our feasible region is this shape right here. So again, kind of like a box. Okay, before we find the intersection points, it's going to help to remove the shading. So we want to change these back to the line symbol and then graph it. Before I find my intersection points, I want to draw my graph on my paper. So I had a horizontal line like that, and a line like that, and then I also had a vertical line here. So this is my feasible region. And we have 1, 2, 3, 4, 5 corner points to find. To find my first corner point, I want to use the intersection command. And I'm trying to find this point right here. So I need to select this line and this line. So it's already on this line, which is y1. So I just need to press enter. So that has declared that as our first curve. Now I need to declare the axis as our second curve. So right now the cursor is on y2, which is y is equal to 5. And we want it to be on y3, which was where we entered in y is equal to 0 in the y equals. So pressing up and down changes the line that the cursor is on. Pressing left and right navigates the current line that you're on. So we can get it to be y3, and then press enter, and then make a guess, and then we find that the intersection point is 2, 0. Next I'm trying to find the points that are on the y-axis. So if I press second calc and then the value command, it will take me to the graph, and I need to type in x is equal to 0 here, and then press enter. And then if we press up and down, it will scroll through all of the different points that are on the y-axis. So we want 0, 2, and we want 0, 5. Finally, to get the corner points that are on the vertical line x is equal to 6, we need to press second calc and value, and instead of typing in x is equal to 0 here, we are actually going to type in x is equal to 6. So instead of giving us all of the points that are on the y-axis, it's going to give us all of the points that are on the line x is equal to 6. And just like with the y-axis, we need to press up or down to scroll through all of the points. So right now it's on 6, negative 4, which is somewhere down here. So if we press up or down, we can get it to 6, 0, and then 6, 5. So we want 6, 0 and 6, 5. Now that we found all of our intersection points, we can label them on our graph. So 0, 5, 0, 2, 2, 0, 6, 0, and 6, 5. So now I just want to plug in these corner points into the objective function. So 0 plus 3 times 5 is 15. 0 plus 3 times 2 is 6. 2 plus 3 times 0 is 2. 6 plus 3 times 0 is 6. And then 6 plus 3 times 5 is 21. So they are looking for the maximum, which is going to be 21. So the max is 21, and this occurs at 6, 5.